Okay, we're on the very far side of the factory. We've come over here to where the amplifiers are made. Could you show us how the production is done?
Absolutely. We have a few desks here where people are mounting amplifiers. So it's always works like this, that we build the amplifier from the ground up. And that means that one person do one amplifier at the time. We don't have serial production in that manner, but one guy is responsible for everything that goes into that amp.
I like that, okay.
What we do is that we work with sub-suppliers around the area, and just next door we have a PCB manufacturer, and they do all our assembly work. So in a sense we are a screwdriver factory, because we did not want to invest into the machinery, and frankly, audio is such a tiny business compared to telecom or whatever goes on in this area, which is very big on that. And because of that, we have very, very good suppliers with a very high skill level. So we get all our PCB mounted, and we have storage of them over here. We can walk over here and have a look. These are the boards for the different type of amplifiers we have. They are lined up here in types. This here is the output board. This is for the M300, which is a monoblock.
I noticed that this is made of copper, and there's advantages to that.
The copper is anti-hysteresis, while aluminium is pro-hysteresis. And that means that when you have something that transmits a lot of current, like the output stage on an amplifier, aluminium would be paramagnetic, and that means that it will actually take and change itself and transmit this paramagnetism throughout the chassis. And that means you get a kind of a feedback inside the amplifier from the hysteresis bleeding into the input stages and whatever, and you really, really don't want that. So by putting copper right behind the output transistors, simply breaks the hysteresis loops, and that's the reason why you want to do it. And sound performance-wise, there's a huge difference. You just have to try to build an amplifier with or without.
With or without, and then,
and you can hear it. It's blurring, it's smearing when you mount your transistors directly on aluminium. I know it's very convenient to do, because you don't want to invest into thick copper bars because they are costly. So by not having these, you can save potentially a lot of money, but you also destroy the sound. There's no way an amplifier with transistors mounted directly on aluminium can sound as good as one where the output transistors are mounted on copper or silver or whatever can break the hysteresis loops. We need to talk a little bit about this one also in the terms that we have a very unique output stage on our pre and power combination. And the P300 and the M300 have a non-switching output stage that always runs in Class A. And the big advantage of that is that the input stage where you put in the feedback does not have to deal with switching residuals. And the driver stage does not have to drain the bases on the output transistors from current, and it doesn't have to charge them afterwards, which will always happen. And that means that you will get switching transients going back into your system. So by keeping the output transistors always in an on state, really makes it so much easier to be an input stage and dealing with the feedback. The reason we can do that is that we have quite a lot of output transistors, and we have made a bias spread. We have 8 pairs here.
I see.
And we have made a bias stage that is not depending on voltage. Normally you make a bias stage where you have a resistor to the signal, and that current going through the resistor creates a bias spread. Here we have made a bias spread with active devices, and that means that no matter how much current the speaker needs, the output transistors will always stay on. So in terms of being Class A, we do that. They are always excess current in the output stage. The transistors does not switch, so those are definite Class A things. The only thing that we don't have is the excess heat, because we don't really need to bias the transistors very, very hot in order to maintain them on. Full on in Class A all the time.
That's very cool.
So it's a cold running Class A output stage, and I think it's very unique in the market.
I think you're right about that. Yeah.
I think we're the only one that has actually cracked the code to
cool.
do that.
Yeah.
Here we have this is a P300, And what you see down here is not only are the output modules mounted on copper bars, we have also the inner chassis is made with a copper coating.
I see.
It's not only a copper coating, because this is actually aluminium, but it's made with a tantal and then copper coating, and that changes the mechanical tone of the chassis. Amplifiers are also prone to mechanical feedback. So if you have something that sounds thin and brittle in the chassis, like an aluminium chassis would do, then you also will get an amplifier that sounds thin and brittle. So you need actually to take into account that the mechanics of your system also influences the sound. And it's not subtle, the differences it makes in listening. It's very big differences. And so if you have a warm, full-bodied tone of your chassis, your amplifier also tends to sound warm and full-bodied. And I think it's also a place where most manufacturers just sort of jump the bar and not go into the extents of this. And transforming the aluminium chassis with a layer of tantalum and copper is quite costly. We put these into a particle accelerator and have them treated there, much the same way as Rido do with their speaker cones. Same machine, same type of process.
I also see this inductor here. This is a key part of the unit too.
Yeah, these are actually Ansuz developments. This is Ansuz cables in here, and like in the DTC cables, we have the active noise suppressants, and we have them here. And the reason why we have them here is that the speaker terminals are part of the speaker wire system. And most often, most of the noise you get in the system are actually radio frequency noises picked up by speaker wires, or acoustic feedback created by the speaker wires. And these noise suppressants kind of prevents that.
How about that? So you've used the technology from Ansuz over into here. You've really doubled down on this. This is great.
I think when you do work in this business, you have to think of components as being a part of the system. And if you can do something in a component to prevent the other parts of the system influencing in a bad way, then of course you should put it in.
Well, I see here you have a new machine in the other room. Can we go take a look at that? I think we do some etching and...
Of course. We have so many parts, and especially when we work with the cables, we have so many different cable types, and they share some of the raw parts, but the labeling of them. And in order to reduce stocks, it's very nice that we could actually baptize them at the last minute, so a part that goes into a DTC cable can be labeled as a DTC part later on in the process. So we invested some money into having our own laser printing, so we have a small machine doing it, and we can of course show the viewers how laser printing looks.
Good, here we go.
So this is, we have a small room here where we put in the laser printer, and it's a real magical machine. Basically what we do is that we have a program here where we have the text, and then we can check here inside the square is where the marking will be, and we can stop that, and then we can just simply start printing. You can see how,
look at that. I've never seen that done before.
oh, it's fascinating.
It is really fascinating. So it's firing a laser down. There it goes. Now viewers, how cool is that? Very good. Well, this is a great tour of your facility. I understand that something very unique. The inside of a Aavik amplifier actually costs more than the outside of the chassis. How about that?
Yeah, I think the process we use when we have the tantal and the copper layer put on the aluminium chassis is so costly that it outshines the rest of the parts that are machined and anodized. Machining and anodizing is in terms of components relatively cheap. They have a very beautiful interior. They are scratch-free. They are very nice. You can clean them. But the interior, when you want to tune the chassis parts to performance, cost money.
Well, great. We have a product here. We have a little setup here for testing at the factory itself. We're going to wrap our tour up at the listening facility. So I want to thank you both for what a great tour today. Michael, you did a great job. Really, I know so much more about what goes into making these products. Lars, thank you very much for bringing us into the factory today. Let's go on and do some exploration of your listening studios next.
Yeah.
Thank you.
Yeah, thank you. Thank you.